Welcome. I'm just going to set up now, start recording. Right. So I haven't streamed for a while now. What I'm going to be working on today, briefly, is a project I'm calling Voluma. It's a voice server written in Elixir, and the idea is that you join a room and then set your position and orientation in three-dimensional space, and the server um, essentially works out which audio streams of the other people in the room to combine, and you get sort of a three-dimensional chat. So I've sort of started off with a pretty high-level acceptance test and a few unit tests. So if we run through this, this is the main acceptance test which I've just gotten to work. So we start a server by calling voluma.start. We get a process ID, and that's not an operating system process, that's an Elixir process, which is so similar to a thread, but it's an internal thing that happens in the Erlang VM. So then once we have the Voluma server itself, we then ask to create a room and give it an ID, string ID. We get back another process, and that process is going to be the room server as opposed to the global server. And if we request from the room server, we pass that process ID through to the room server module and ask it to retrieve room data. We then see we get the room, and we also get a process ID for two supervisors. Now in Elixir, you create a tree, a supervision tree. So I'm wondering if I can diagram this out. You know what? You'll just have to take my word for it. Okay, so essentially under each room we have two supervisors, cells and memberships. So essentially the cells supervisor ensures that for each discrete area of space there is a server process managing all the streams inside that space. Then the memberships supervisor does the same thing but for users. So essentially every user is going to have a server, a gen server, which is a concept in Elixir and Erlang. So that server is going to handle all the receipt of audio stream from each individual user. And then each cell, if you imagine it as sort of maybe a 1 meter cube, so every meter cube in three-dimensional space gets given its own cell. It would probably be bigger than that when it's used. So that means that the cells manage, they essentially collect audio streams from all users inside them, and it's a way for us to, I suppose, simplify the stream processing. So at this point, we then we create a user struct. So we have an ID, and then we just have a name, and we tell the room server to add a user, and what we get back is a membership object, a membership struct, and that has a process ID as well. So that's going to be a child process of the membership supervisor, which is this thing here. We then set our position at X position 2, Y position 2, send that to our own personal membership server, and that's going to update our membership in the room with our position, and it's going to work out which streams in that room we should subscribe to based on our position. Then what we do is we request our status and make sure that our position's set. We start streaming, which is sort of just doesn't do much at the moment, but then we essentially do the same thing with a second user, and before the second user sets their position, we ask for subscriptions. So it's sort of like we're asking which audio streams this user is subscribed to in the room, and until we set a position we don't have any subscriptions. But then when we set the position, we see that the subscriptions are no longer empty, and what we'll find is actually that subscription is going to be to the cell that the first user is in. So there's going to be a cell at position 2, right? And the second user, when they join the room, they're going to subscribe to that cell. And then what happens is the first user streams some audio. At the moment I'm abstracting that away, and it's just a series of integers or numbers in Elixir. And then we wait a little bit, and then when the second user pulls five items off their buffer, we get a stereo stream left and right. And at the moment I'm treating this as like a mono stream, just until I get the stream routing working, and then later on we will be doing orientation and panning different users and different cells, or different audio streams. We'll be panning them based on their orientation to each individual user, but that's further down the road. So what I'm going to be trying to do today, I don't have too much time actually, but I realized that my original architecture of this project was based on sort of a subscription system, but I believe the more I explored it, I needed to sort of work more on a push rather than a pull sort of mentality. So I'm looking to perhaps refactor this so that instead of subscribing to cells, essentially we detect broadcast targets. I suppose that's what you call them. Consumers. We essentially, when we set our position, instead of working out who to subscribe to, what we'd do is we'd work out who to publish to. So we might need to update our test a little bit. So I'm guessing the first point that makes sense here is before you set your position, you're not going to have any consumers. I wonder if I might just comment out the parts of this test that focus on subscriptions. And make a branch. Call it push, not pull. Okay, so we're not going to assert anything about our subscriptions. which was a significant piece of work actually, but I don't know, sometimes you need to make mistakes in order to get architecture of these things right. Okay, so I'm guessing what happens is before we set the position, I do not so what we expect is to request from our membership server consumers. We need to send with this call a membership PID so that we can locate our particular server, and it's always the first argument, it's the PID when working in Elixir with Gin servers. I think that's the only argument we need for this. We're going to get an error, which is good, what we expect, and so now we need to implement that on our membership server. So what we'll do is we'll define the consumer's public API, which is going to receive a PID and nothing else. And this is going to be the call. So the interesting thing about this is that this particular, in Elixir, when you call consumers, this method, this function, is not handled by the server instance yet. Instead, we need to use this call, which we import from the Gen server module, to find the PID and then call this tuple on the server itself. So this isn't actually getting evaluated within the server instance, which is sort of a weird functional way of basically how Elixir and Erlang do state, is that you have functional servers that are just loops. So you don't really have any state, but you are recursively calling the server in a loop, and the return value is the argument for the next loop. That's how they do state functionally, because everything in Elixir is immutable, which is really cool, but also can be a little bit weird and annoying to work around sometimes. Anyway, so what we're going to do is we're going to send the consumer's message to in a call to that server. So that's going to have another error because we don't have a handle for that call. So if we handle a call here to consumers, and we're going to get a from, which we proceed with an underscore to show that we're not actually going to use it. From is basically the address, the PID of the server, I suppose it is, that's calling, making this call. So it's like essentially everything is message passing. So behind the scenes, that from PID is used to send a reply back to the other server, because everything's happening asynchronously, almost like every Gen server is a little bit like a neuron sending synapses. So these handle calls and handle casts are sort of like one neuron to the other, and each neuron is just a loop, a function looping over and over on itself, and that's sort of the architecture of Elixir, which makes it a really interesting ecosystem to work in, because a lot of programming languages don't really have that paradigm. Sorry, I've spoken a lot. So let's handle this consumers thing. So right now, instead of using the shorthand, I'll use the longhand, just so it's a little bit clearer. So right now, there's never going to be anything but empty consumers. Now we can't just return a value from this, because this is all happening asynchronously. We expect to follow a because this handle call is a callback for gen server. So what we do is we not okay, we reply, and we give our reply as the second item of the tuple, and then finally the third item is going to be the new state of the system. Okay, and oops, we want to return another tuple in there. Okay, so that's good. We've now handled that. So basically, whenever you ask what so you're asking your membership server, which other servers are consuming my stream, or do I need to send my stream to? And right now we just handle the null case, which is none. It's fine, empty. So at this point we've got another error. It's because I haven't commented out line 72. Okay, so interesting. No functional process subscriptions. Membership server process subscriptions. I'm not sure why that's. Oh, it's because okay, we don't expect that to pass at this point. So we can comment that out as well. And oops. Response. Okay, I'm sort of gutting my acceptance test here. Alright, so we're back to green. Okay, so now if we request our consumers, we don't have any, but when we set our position, suppose we still don't have any. So what's going to happen then is the second user is going to come. And I guess a better, so what I'm going to do is I'm going to simplify this. Joining and transmitting in the same cell. And transmitting the same cell. So let's not worry about cells, the different cell routing just yet. Let's just focus on two users at the same position. Okay, so we set up a second user joins the same way, and don't need that position. So we set position of the second to the exact same position. In fact, we can extract this here. We don't need to define it inside the test itself. Oops. Okay, and now okay, that should be green. Cool. Interesting. Okay, so once the second user joins at the same position, we expect the cell knows who's in it, right? So the room.cells_pid, right, is going to be our cell supervisor. Or should we, let's say our cell is equal or matches if we ask our membership server to get the cell for our membership to the room. We might use membership 1. Okay, so I see who else is in my cell. Oop, that's a syntax error. So we get cell like that, right? Cool. So get cell is undefined, that's fine. Let's just set that up. Okay, so this is just another call. So if we define get cell for PID, it's just going to be a call to get cell. Okay, and now we're going to say, oh, no handle for that. So let's handle it. Handle the call, get cell. Don't care who it's from. And we will reply with a tuple of OK, and one can only presume a cell. So what does the cell look like? I should say it's nil for now. So green. What else can we assert? So we should, it should have a PID, right? And that's not, okay. Cool. So what we can do here is we can io.inspect the state. And I believe the state is actually a cell object itself. Logger.horn state. Oh no, sorry, the state is going to be a membership. A membership object. There we go, that one there. So we've got a membership, oh, we've got a cell PID. Wait, do we already have a cell PID here? So when we set our position, what we really want is a new membership, an updated membership. Because that membership is going to contain our cell. So if we go back, instead of receiving OK by itself, we're gonna get a new membership here. So that's going to fail. Boop. Cool. So instead of just casting our request, what we're going to do is change that from a cast to a call. So basically a cast is a call with no reply. So you just sort of cast off your request and don't really care about what comes back. But a call expects a response. So we're going to change that. And now our handle cast needs to become a handle call. You can see this is quite an involved function. Okay, let's put it up with the other handle calls. And the state, the membership. So we get an additional argument, which is the from. Casts don't have replies, so they don't receive a from address, PID, but they do. So here we go, and we just want to reply with our new state, which is the membership. And then that third item is a tuple, which is the new state. So this item here designates the response as a reply. This item here in the middle designates what we're going to send the requester, and this item here designates what the state of the server is going to be when it gets its next request. So it's only coincidence that these are the same. Okay, so we're not getting a match here, so we're getting a membership. So when we set position at line 39, do we have? Elixir over. So I'm trying to remember. I don't think I need to do anything special here. So what's it saying? Oh, that's why. I need to return as my response. It needs to be a tuple itself. Okay. Interesting. Okay, let's restart this. So I'm using the mix test watcher so that, okay, looks like we're creating the same user 2. I see what we're doing. Pardon me, I'm thirsty. Okay, so originally in my test, both users were joining different cells. So we had this thing called ensure cell. But if two users join the same cell, we're going to try and start a server for that cell twice. So the way we get around this is we case the response. Oops, no, I'm getting confused with Ruby. So when it is okay PID, then so cell PID is equal to that. When it's OK PID, that's fine. But if the response is an error already started with a PID, then it's fine because we have a PID. And then we just return OK cell PID, and that should pass. Well, at least that part of the test. Interesting. Okay. So now, where's that failing? On line 52. Yep. So let's go back to our test, and on line 52 we now get an updated membership when the second user joins, sets their position. Good. So now we don't need to ask our membership to get the cell. We can call the cell server directly and say users. No, it's going to be memberships, I believe. So get memberships of my membership. So my membership has a reference to the cell server, which is going to be a PID. Now if we use that PID to request our personal cell server, and we're going to request all the memberships that cell knows about. Now this is going to fail because there's no get memberships, but that's fine, we add it. So in our cell server we have, under our public API, we're going to define get memberships with a PID. And what that's going to do is that's going to trigger a call, and I hope this comma do colon doesn't confuse you. It's just the shorthand of doing a single line function in Elixir, which is very nice and tidy, I think, concise. And so we're just going to trigger a call to get memberships. Right, now we're going to get another error, which is there's no handler. So we need to handle a call to get memberships, and I'm going to reply with OK, and the state dot memberships. Cool. Now we need to assert that those memberships I suppose we need to assert that the length of memberships assert is equal to 2, right? I'm wondering, oh, is it len? Elixir list length. Kernel.length. Okay, so before we do that, let's logger.warn just make sure that that's so we've got a map set, an empty map set. So it's because we're not, okay, the reason why this is failing is because we are not operating on a list. I forgot this is actually a map set. So a map set is like a set in Ruby backed by a dictionary. So essentially you can add items to it multiple times and it only remembers the first item, if that makes sense. So it's good for identifying membership. So it's got a size, mapset.size. So what we want to do is we want to assert that the mapset size of memberships is equal to 2, and it's not. Oh, it's because of the weird order of operations, I think. Okay, here. Right, so we've now got our first, like, interesting failure. So, right now, when we set, can delete that. I don't think we need that anymore. Nope. So set position is our most interesting So we don't need subscriptions anymore, right? So when we ensure our cell, we send a cell PID to the supervisor. So that's the cell, the room cells PID, not cell PID, but cells plural PID. Refers to the supervisor ID, process ID. So we're saying this process that's managing the life cycle of all the other cells, we tell it to ensure that there's a cell for this particular room and our current position. I don't know why we're sending the room. Let's have a look. Cell supervisor. What do we do with the room? Oh, so the cell has a reference to the room. I don't know if that's required. We might be able to tease that out later, refactor it away. So I guess what we really want to do is when we ensure the cell exists, let's check my levels. Yeah, they're all right. So okay. So we ensure the cell. We send our membership. Okay, so it looks like we only really need to send our membership and our position here. We can assume everything else from those, work out everything else from those values. Okay. So this is going to change quite drastically. So if we ensure the cell, we're getting a membership. So we can say put an equals here, and that just makes sure that it matches the structure of the membership model. So the ID is sort of just a an identifier, so x-y in a string format so that we can use it to identify stuff. So we start a child, we give it the ID of the position to ensure it's unique. We start a cell server with room and position. I think we just give it membership and position instead. Then, okay. Cell supervisor 18. Okay, so the PID is no longer so it's going to be the membership dot room dot cells PID. Interesting. Why is this happening? So we called set position. Okay. Let's run our test outside. Okay, how do we get back to green? Error bad key. Oh. So I think we need to update the cell server to receive a membership permission. So we start, instead of getting a room, we get a membership. And I'm going to make sure that these are matched, so we can get a membership and position. Okay, something's gone wrong. Cells. Oh, I thought I just did that. Membership dot room dot cells PID. Okay, where's the room coming from? Cell server 15 room equals membership dot room. Okay, so we're now back to our original okay, so I don't have very much longer. So essentially what we do is when we start the link, we need to pass it the membership instead of the room, and then on this init we're going to get a membership. The room is going to be equal to dot room, and then memberships is going to be a mapset dot new oh, I've got it right there. Nope. Mapset new. We give it a list with the membership. Okay. So now we've got one membership in the room. Now the final case is that when when we ensure the cell, that when it doesn't exist yet, that's fine. However, when it does exist, what we're going to do is we're going to cells server add membership. We're going to give it the PID of the cell that already exists and pass the membership. Right? Now that's not going to exist, so we add it to the public API, def add membership. It's going to take a PID and a membership, and we're going to call the server instance with an add membership. Well, it's going to be a tuple, so we actually do it like that. Okay, now there's going to need to handle a call, which is going to be add membership, but it's going to be wrapped in a tuple. The membership, and we're going to return the new memberships. So new memberships equals the state.memberships, but we pipe that to mapset.insert, is it? Mapset put. Mapset put membership, and then so the new memberships is going to be the return value new memberships, and this new state is going to be equal to the old state that we merge in and replace the memberships with its updated value. And I think that should be green. Nope. Oops. New memberships. Interesting. Add membership 2 is undefined. What? Cells server. Oh, I got mixed up. So here it's not a cells server, it's a cell server. Boom! So now when two users join the same cell, we can now see that they're members. Cool. Well, I'm going to leave it there. Please feel free to send any comment any questions, and I'll do my best to answer them. You can find me on devbrett.com. And yeah, thanks for watching.